Okay, so what today we're looking at similar triangles. So yesterday we did similar shapes. This is still the same process, and you can still do all the same things with the similar triangles. And it's now today what we're going to do is we're going to get asked to prove first maybe that they are similar before we go on. So yesterday I told you a lot with the other shapes, they'll tell you in the question that they're similar. Sometimes with the triangles, they don't tell you. You need to work out that they're similar, and therefore you can do the scale factor and the area scale factor and things like that. So we're going to look at how we can prove two triangles are similar. And there's three sort of reasons we can say they are. And the first reason is here, and it's if all the corresponding angles are equal. So you can look up here in this example at the top there. So if you've got, we can see that that one's 55, that one's 55, and they've said that both the top ones are 35. So because you only need to know two are the same. Why would you only need to know two? Because we know a triangle adds up to 180. So if two of them are the same, the other one has to be the same, okay? So if we see this reason, if we see these triangles and we see two angles are the same, we're going to say the triangles are similar. And you can just write it like this. See how I'm not writing out a whole sentence. Just going to say triangles are similar, and I'm just going to say because angle, angle, angle. Okay, sometimes I only write two, AA, because you only need to know two are, because the third one is then implied, but we'll just write three angles. We know the three angles are the same, AAA. Okay, the second reason that triangles could be similar is that we're going to say all the sides are in the same ratio. So that was sort of like what we looked at yesterday in terms of the scale factor. So when we say the sides are in the same ratio, so have a look here. If I say I'm going to call this the new object and this one the old, okay? So I'm going to the same side of the triangle. So if I said 4/2, that simplifies to 2, doesn't it? Now, if I check the other side, I'm going to use the bottom side. So if I say 5/2.5, does that equal 2? It does, doesn't it? Yeah? So that's gone up by the same amount. And if I test this last one, we've got the 2 and the 1. So if I do 2/1, yeah, that equals 2. So you can see they're in corresponding ratio, means that they've all been enlarged or gone up by the same amount, same scale factor, which is 2. All right, so if that's the case, if you can see all three sides have been changed in the exact same way, you can give your reasons. You can say triangles are similar. Let's write that out a bit neater. So triangles are similar because of side, side, side. We can just write SSS, that's fine. All the sides are in the same ratio. And you might, if you've got to prove it, just do that little working out like what I've done. I've shown all three sides give the same fraction or the same number. Okay, and then the last reason we can have that we can say triangles are similar, it's when we have two sides of the triangle have been the same ratio and the angle in between them. Okay, so what you can look at, so we'd have to compare the side. We can see straight off reading, we've both got a 30 degrees. So we go, okay, the angle's the same there. So what we're going to do is check if the corresponding sides are in the same ratio. Means would they produce the same number? So if I do 19.5/6.5, I get 3. Now if I check the other one, the 21 and the 7, if I do 21/7, I get 3. So I know the two sides in between that angle have been enlarged by the same amount. So if that's happened, the triangles are similar. So you can say triangles are similar, and we'll just say because, and this is where we go side, angle, side. Now we have to write it like that with the angle in the A in the middle, because we're saying it's in between those two sides, which is what it needs to be. It needs to be the angle in between the two sides that are corresponding. Okay, so that's all you have to do. You don't have to write big statements, just write that and show me the little bit of the working out to prove it. All right. Okay, so with this question, it says explain why triangle ABC is similar to triangle XYZ. So I'm going to have a look here, and I've seen that I've got an angle that's the same, and it's the two including sides. So, all right, I'm going to check that the corresponding sides have gone up by the same. So I'll call this the new and this the old. So we like to do the new number over the, so I'm checking corresponding sides. So 21 over 7 equals 3. And does 24, I'm doing the other side, 24 over 8, that equals 3, doesn't it? So I'm going to say triangle ABC is similar to triangle XYZ, and we're just going to say because of side angle side, okay? And if you've shown that little ratio like I've done, all good, you get the mark. Here it says two triangles are similar, so I already know that they're similar. I don't have to prove it. And it says you've got to find y, obviously. So here's where, like what we were doing yesterday, if they're similar, the corresponding sides will equal each other. So that means if you put them as a fraction, they'll equal. So I'll just call this the new image and this the old one. All right, so if I go 5 over 25, because I know they are already similar, I know that's going to equal the same as if I do 4 over y. So once you have that equation set up like that, that means we can use the solve function on our calculator, so comma y, and you'll find out that y equals 20 centimeters, okay? So that's okay. So that's what we're doing. We did that yesterday, pretty similar scenario. Now over here on this next one, we have the same situation, but you need to be super careful because they're not displayed like, you know, side by side. They're not actually in the same position. So what you want to do is you actually want to take this one and probably redraw it. Turn around and turn it around like that so that it's actually matching, so you don't get confused when you're comparing the corresponding sides. So what I'm going to do is I'm going to compare, I want to find x and y. I have to do two separate equations, so I'm going to use the 10 and the 20, and I'll call this, I'm going to call this one the old, this one the new. So when I work it out, I'm going to say 10 over 20 should equal, and I'm going to, if I do x first, it should be x over 52, okay? These numbers are maybe a bit easier so you can work them out in your head, but feel free to use your calculator. So we'll get x equals 26, and then you can use that same ratio to find y, that y over 48. Okay, so just be careful, probably worth redrawing your triangles to look in the same way so that you don't accidentally make a mistake in comparing the wrong sides. Okay, and then y ends up being 24. This was in meters, so we'll pop that answer in there like that. So they've given that the area of the small triangle in the following diagram is 2.4 centimeters squared. Find the area of the larger triangle correct to 1 decimal place. So if you were given this, you're obviously being told to find the area. So it means that they're most likely, it has to be, without any other information, we must know that these triangles are similar. So just to prove it to you and to show you, what happens is when you have parallel lines, so with those arrows on those two things are showing parallel lines. And if you remember last year, so if you have parallel lines and then you have a line cutting through here. So if I drew them just as lines, like here, make it a bit easier. Remember when we had a cutting line through that? Do you remember last year we said those angles are the same? Remember corresponding angles were equal? Yeah, so if that was, say, 20 degrees, that would be 20 degrees in the pattern. So what we're seeing here is we're going to say, even though we don't know what it is, we do know those two angles in those triangles are the same. Now we also have, if you look here, they both share that angle. So if I redrew these triangles out, so if I had my if I had my small one and then I had the large one, I'm drawing them out separate. So what I've said is this angle is the same, and I said they both had that angle in there. So if they both have two angles the same, we're going to say they're similar because of angle, okay? So now we know they're similar, it means we can use all that scale factor and the ratio and things like that. So what we actually have here, we know that the bigger one is 7 and the little one is 2. All right, so I'm going to use that to find my length ratio or the scale factor. So I'll just call it length ratio or scale factor, which remember we said was the letter K. So we said we took new image over old. So I'm just going to call the big one the new one and the little one the old one. So my scale factor is 7/2. Now, if you remember to yesterday, how did we find the area ratio scale factor? We squared our K. So what we're really saying, this number here is like our K. So our area ratio is going to be 7/2 squared, which could also be written as 7 squared over 2 squared. That means the same thing. Or if you actually square it, 49/4. It doesn't matter which way you pop it into your calculator, as long as we use one of those. So you can do any of those. So what we're going to say, when we know the area ratio, we're going to compare them. We know if we said, so I'm just going to say 7 squared over 2 squared, like that. I'm going to write it like that. We know that would produce the same ratio if I said area of the large triangle over area of the small triangle. Okay, so I can set up an equation. I can use this, and what I'm going to say, I do know what the smaller area was. It was 2.4. They told me that, and I don't know. I'm going to call the area of the big one, I'm just going to call it X. So I don't know what that one is. So once I do that, what do you think I'm going to do now? Yep, I can hear someone saying it. What is it? Solve. Good. We've got an equation. We can do solve, comma, X, and we'll find out what the area of that large one is. Okay, so we got X equals 29.4, and it will be centimetres squared. So you write the large one. Just be careful. I've already noticed when a few people are doing their calculations. Just note, see this is the larger number, isn't it, in my ratio? So this would have to be opposite. It would have to be the large area of the triangle, yeah? This is the small number in the ratio, so it should have the small area following along that way, okay? All right.